Hello everyone, welcome back. So I'm making a video because there's been some problems and concerns and some questions about how to find the differential rate law or the rate law from a data table. So let's just kind of do another example. Let me walk you through it. We're going to first find the rate law, then we're going to show you how to find the K value with the units. And then we'll kind of just walk you through a little bit of how to find a rate from there or things like that. So what I have behind me is just a data table. I just pulled this off the internet. I just Googled rate law problems, and so this is one of the first hits. So I've got two reactants here. I've got a concentration of A and concentration of B, and a rate, and the rate changes. And then they just do 4 different experiments for 4 different trials. So I'm just going to step off to the side so you'll get a chance to write this down. And then we'll kind of just go through how to solve these problems. Okay, so hopefully you got a chance to write it down. And so our rate law is going to be in this format. It's going to be rate equals K times the concentration of A to some nth power, and we'll determine that n number from this data, times the concentration of B to some mth power. Okay, so what we're really trying to calculate when we find the rate law are what are these two values right here? What are our n and our m? Because we don't quite know what those are yet. Okay, so let's start with A. So in order to figure out what A is, or the n value right here, we need to look at just how A is affecting our rate. So if we go over to our data table, we can see here's our A values, and they're changing. It goes 1.1, 0.3, 0.1, 0.2. But our B values are here, and our B values change as well. So to figure out how A only affects the rate, we need to find a time when B is held constant, when B doesn't change. What we can see right here, between trials 2 and 3, B is held constant. Okay, so between trials 2 and 3, B stays the same. So B is not affecting my rate whatsoever. Only A is affecting my rate because B is not changed. Well, if we look, you'll notice between trials 3 and 2, the concentration of A is either tripled or cut by 3, depending on how you look at it. So let's do between 3 and 2. So in trial 3, my concentration is 0.1. In trial 2, my concentration is 0.3. So my concentration triples, right? My concentration triples. The difference between 0.1 and 0.3 is 3. Right? My concentration triples. Okay? Well, and if we look at our rate here, so I'm kicking these toys and they're making all these sounds. And, all right. My rate between trials 2 and 3, or 3 and 2 I should say, notice my rate goes from 3 to 9. So as my concentration increases by a factor of 3, my rate also increases by a factor of 3. Okay. So, and when my concentration and rate change the same amount, that's called a first order reaction. Okay, so my concentration triples, and my rate triples. So that's A to the first order. So I'm going to erase my n right here. That's going to be first order. It's first order in respect to A, it's said. Okay, it's first order in respect to A. Well, that's great. So now let me do B. So now I need to find a time where A is held constant, where A is no longer going to affect my reaction, my rate. So if I look, A is held constant between trials 1 and 3. Okay? A is held constant in trials 1 and 3, so only my change in B would affect my rate. Only B's change affects that rate. Well, we notice between trials 1 and 3, now B increases by a factor of 3. Right? Between trials 1 and 3, it goes from 0.1 to 0.3, so now B increases by a factor of 3. Well, if I look at my rate between 1 and 3. Now I'm looking at my rate between 1 and 3. And I know I have a lot of numbers. Let me just erase this here. My rate stays the same. Where it increases by a factor of just 1, right? It stays the same. I'm multiplying it by 1. So what this is saying is I'm changing my concentration of B, and it has no effect on my rate. So I am tripling my concentration of B, and my rate remains constant. So that means that this is 0 order. Let me write over here. This is 0 order in respect to B. It's 0 order because B does not in any way affect the rate of the reaction. Okay? B does not affect the rate of that reaction. So we said it's 0 order. Okay? Now, anything raised to the 0 power is just 1. So anything raised to the 0 power is just 1. So to simplify my rate law, I'm just going to get rid of B. My whiteboard's a little old, so it took a little bit to erase that. So right now, rate equals K times the concentration of A to the first power, or K times A. Okay, so that's how I find the rate law given a set of data. Now someone would be like, okay, well that's great, that's dandy. How do I find K value? Because the next problem would be to find the K value. Because just finding this doesn't really help me at all. I can't do anything with this. My whole point of this is to be able to calculate at any given time how much reactant and how much product there is. And I can't do that with this because I have no numbers. It's just an equation. It's first order. That's great. It moves the same amount. But I need some actual numbers to grab hold of so I can predict rates. I can predict concentrations. Because that's what's important about this. So what I'm going to do is I'm going to pick any trial I would like. Any trial I want. And I'm just going to solve for it. So I'm going to do trial 1 because I always pick trial 1. I don't know why, I just do. So I'm going to plug in the rate for trial 1 right where it says rate. So that's 3.0 times 10 to the negative 4th. That equals K times the concentration of A. Well, in trial 1, my concentration of A was 0.1. Now, hopefully, it's very easy to see how you would get K all by itself. I'm going to divide both sides by 0.1. All right? And that means that if my mental math is correct, K equals 3.0 times 10 to the negative 3rd. All right, I should be correct. Let me just double check because, boy, would that be embarrassing if I got that wrong. So let's 0.1, 2, 3, 4, divided by 0.1. Yes, it is. Okay, I was right. I was just doubting myself. Okay, so this is my K value. So now I could plug this in for K. I could plug that in for K. That's my K value. Now, K has a unit. K needs to have a unit. The problem is, though, K's unit is just whatever it has to be to get my rate and concentrations to work out. The unit on K is essentially meaningless. It doesn't matter what it is. It's what you have to use to make it work. So, we have to figure out what our K unit's going to be. And the way we do that is we just plug in our units for our variables instead of numbers. So here we plugged in the actual number for the rate and for the concentration of A, but we're just going to plug in just what the variables are, the units are. Now I forgot to tell you here that concentration, this is measured in molarity, and this is measured in, we'll call it molarity per second. Okay? So now I'm going to do the same exact thing I did here, but instead of numbers, I'm going to plug in units. So rate, my unit for rate is molarity per second. That equals K times the concentration of A, which is molarity. Okay? I want to get rid of molarity. I want to get K all by itself. So what I'm going to do is I'm going to multiply both sides by 1 over molarity. That means that those cancel out. So I'm going to multiply both sides by 1 over molarity. Multiplying both sides by 1 over molarity is the same as dividing by molarity. They're the same exact function. I could, let's say, instead of molarity, I could either divide both sides by 2 or multiply by 1/2. They're the same function, right? Dividing by 2 and multiplying by 1/2 is the same thing. And it's just like this. I could divide by m, or I could multiply by 1 over m. It's the same exact thing, right? Multiplying by 4 or dividing, multiplying by 1/4 or dividing by 4 is the same concept. It does the same thing. I can do the same thing here. But it's just easier for me to see now that this molarity and this molarity cancel out, so my K value is in 1 over S, which we sometimes write as seconds to the negative 1. Okay, so I have found my rate, or I'm sorry, I found my rate law, I found my K, the unit on my K, let me plug my unit in here now, it's seconds to the negative 1, which is the same thing as 1 over seconds, that's fine. And so I'm essentially done. So my rate law, my new revised rate law, I'm going to write right down here, is rate equals 3.0 times 10 to the negative third inverse seconds times concentration of A. Now, as long as I have either the concentration or the rate, I can calculate the other one. Right? If I have the rate, I know what I can figure out what the concentration will be. And if I have the concentration, I can figure out how quickly the reaction is proceeding at that point. So this allows me to do a lot. Right? I mean, rate is the speed of the reaction. So if I know my concentration of A, I'll know how quickly the reaction is proceeding. And if I know how quickly the reaction is proceeding, I'll know my concentration of A. Okay, so this is how you figure out the differential rate law, or more commonly called just the rate law, from a data table. Okay, this is how you calculate from a data table. It's a lot of things. There's quite a few steps here. All right, I know I made it look simple, or it's very, very confusing because the person next to you in class may be able to rip right through it and figure it all out. But it's not that it's necessarily each step is hard, but there's just a lot of steps. And there's a lot of places where it's very easy to forget one thing or forget another thing, and they all pile on top of each other, right? If you can't figure out the rate law, well, you can't figure out K. And if you can't figure out the rate law, you can't figure out your units of K. And you couldn't predict an unknown rate if I had another child on here. So they all build on each other, and there's just a lot of things to remember. So please don't get overwhelmed. You can try this out on your own. You can try this again. There's plenty of rate law questions in your book, in the Fast Track to 5, or just Google rate law problems. There's 1,000 rate law problems. YouTube has hundreds of thousands of videos on people solving rate law problems. So don't get discouraged. Just remember, it's practice, practice, practice. All right? Good luck. I hope this helped, and I will see you in class.